Hello everyone. Myself Sudhir Pandurang Soma. Presently, I am working as a lecturer in Mechanical Department, Brahmadev Dada Mane Polytechnic, Belati Sula. Today, I will deliver a lecture on a stress strain curve for ductile material and stress concentration, and what are the causes of stress concentration. Then, after we study the exactly remedies about for reducing stress concentration. Before we have to see stress strain curve for ductile material. First of all, we should know what is meant by stress and strain. So, what is meant by stress? Stress when an external force is applied on a body. Some of the internal forces are developed. So, these forces are to resist that external force, means the internal resisting force is called as stress. Obviously, you know stress, it is the ratio of force upon area. Then after, what is mean by strain? Strain means it is the elongation, it is a deformation, means it is the change in dimension upon original dimension. Okay, so for it, the stress strain curve for ductile material. So what is mean by ductility? Ductility means it is drawn into wire or elongation. Means it is drawn into wire or elongated. You see the one specimen has given. So that stress strain curve means we take a simple specimen and it is loaded under tensile force, that is the tensile stress. So you see the exact behavior between stress and strain. Okay, you know all the properties of elasticity, plasticity, mechanical properties. Okay, so these are the number of limits, that is the proportionality limit, elastic limit, yield point, ultimate stress, breaking stress. We study one by one. If you see the point O, this is the origin point. You see the line OA represents the stress is directly proportional to strain. This is known as proportionality limit. Means if a specimen is loaded under tension, if load increases on that specimen, the stress is directly proportional to strain. Means it gets elongated so that it will draw directly straight line. Okay, so this line OA means it is known as proportionality limit. Proportional limit. Then after you see elastic limit. Obviously you know elasticity. Okay, it is a property of virtue of which it regains original size and shape when after load removed. Okay, you know the properties of elastic material. When that specimen is loaded beyond this point A, okay, up to the point B, the line AB is represents elastic limit. Means up to the point B, the material has the elastic properties. When load is removed after point, means up to the point B, the material has regained its original size and shape. So that is called as elastic limit. Okay. Then after you see yield point. In that you see C and D. It is the upper yield point and lower yield point. Means at this point the material regains some high strain, means higher stress required higher strain. Okay, so this is at this point, yield point, when increasing the stress, the plastic stress will reach. Means up to this point the elastic property has not reached. Means when the material is loaded after the change in at size and shape will not occurs. Okay. Thereafter, you see the ultimate stress. Ultimate stress, the the material will be stressed after this point T. It will not occur any change in the dimension. Okay. Thereafter, breaking stress. When material is stressed beyond the point of E, that is when the load is applied on that specimen, the material will change its size and shape. Means it occurs a neck formation at some point, at some dimension. Obviously, it breaks after applying continuously load. That point is called as breaking stress. Okay. So then after we will see stress concentration. Okay. The figure shows stress concentration of that concept. Okay. So what is meant by stress concentration? It is a location of any type of machine component. Okay. It is a location formed on any type of machine component. Okay. You see the flow of forces or stresses. A job, a specimen is loaded under tension. Okay. The crystalline structure will changes. Obviously, these load flow lines packed together in this area and stress concentration occurs. Thereafter, lower pattern will show the flow lines are forced together by smaller section. Okay. The material is stronger when the total load is applied is evenly distributed on that cross-sectional area. Okay. The stress concentration will occur at number of areas, means keyways, holes, grooves, notches, threaded components. Okay. Due to their functional requirement to perform that functional requirement. So, you know what are the exact causes of stress concentration. Okay. You see the number of stress concentrations. So, what is meant by stress concentration? It is the abrupt change in the discontinuities, means abrupt change of cross section. Okay. So, due to this, the discontinuities are developed in the areas. So, first cause, that is the abrupt change of cross section. The next, pore surface finish. The next, localized loading. Then after you see variation, the material properties. So, abrupt change of cross section means what? If the material is uniform, then the stress concentration will be different. But if there are holes are present, threaded components, keyways, blowholes, or anything, number of. Okay. So due to this, the stress concentration will be occur at that point. Okay. So next, poor surface finish. If the surface finish is not properly done in between two mating parts, obviously that there will be stress concentration will be occur. Then after you see localized loading. You know the load will be acting at any section will be uniform. If sum of load at acting at corner is more than, obviously that section will be stress concentrated. Then after you see finally the variation in the material properties. You know, while designing any type of component, the designer has to keep in mind all the mechanical properties of materials. He will know about strength, ductility, plasticity, toughness, hardness, grip. Okay, so that this point will be taken into consideration while designing any type of component. Then after, how these will remove, means what are the remedies for reducing stress concentration. You see the number of components are there. You see the first point, that is the by taking one example, tie rod with one hole. So this is the core section of the component. Means this part will occur fastly, that is the stress concentrated area. So how to overcome? You see the next figure, that is a number of holes are increasing around one hole. Means this is the example by providing drill hole at nearby places at one hole or second hole. Then you see the shaft with keyway. A shaft is present in one keyway. Obviously, the stress will be concentrated at this big section. So, how you will remove that stress concentrated? So, you provide some holes at keyway near place. Okay. So, then after you see one rod a specimen will be loaded under tension. It is not affordable, means this section sharp corners should be avoided. Okay, so that sharp corners avoided by replacing some fillet, some radius will be provided, so that obviously stress concentration is divided. So after when you see these types of cross sections, stress distribution pattern will not longer hold. Okay, so due to this, the number of discontinuities are available or produced. So by altering, you know the effect of stress concentration cannot be eliminated permanently, but its effect can be reduced by altering the geometry of the machine component. Okay, thank you.